For centuries, we've thought of gravity as this fundamental force of nature, right? The invisible string that holds the entire cosmos together. But what if that's just wrong? What if gravity isn't fundamental at all, but something that, well, bubbles up from a deeper reality made of pure information? This is the radical idea from physicist Erik Verlinde. And let me tell you, it's a theory that could rewrite everything we think we know.
So, our journey into this idea starts with a really profound mystery. When our astronomers look out at the universe, they find that everything we can actually see, every star, every planet, every galaxy, is just a tiny, tiny sliver of what's really out there. And this chart, wow, this really shows you the sheer scale of our ignorance. This is the energy budget of our universe. See that little 5% slice? That's ordinary matter. Literally everything you've ever seen or touched. The other 95%? A complete and total enigma, split between something we call dark matter and an even more mysterious thing called dark energy.
And here's the real problem. Our absolute bedrock theories of gravity, the masterpieces from Newton and Einstein, they just don't work on the grand scale of galaxies unless we add these giant invisible components. We basically had to invent 95% of the universe just to make our math work. Think about that.
So this leads to a pretty provocative question. Instead of searching for all this missing stuff, what if our theory of gravity itself is what's missing something? What if the theory is incomplete?
Now, to even understand how a radical shift like this is possible, it helps to look at history. Because believe it or not, this wouldn't be the first time our entire idea of gravity has been completely turned on its head. For more than 200 years, Newton's idea of gravity as a force was absolute law. Then, Einstein comes along and completely reframes it as the curvature of spacetime. Then, in the 70s, this whole dark matter puzzle appears, and now Erik Verlinde is suggesting the next great leap forward.
Just stop and think about how wildly different these two ideas are. Newton saw a mysterious pull. Einstein saw this dynamic cosmic fabric being warped and bent. It just goes to show you that what we perceive as fundamental can actually be a sign of something much, much deeper going on.
Okay, so to really grasp Verlinde's idea, we need to get our heads around a key concept from physics. It's a little counterintuitive, but it explains so much about our world. It's called emergence.
Emergence is basically when you have a large-scale property, like, say, the wetness of water, that comes from how countless tiny parts are interacting, in this case, H2O molecules. But here's the thing. That property doesn't exist for any single part on its own. A single molecule of water isn't wet. Wetness emerges from the crowd.
Let's take temperature. That's a perfect example. A single individual gas molecule doesn't have a temperature. The idea is meaningless. But get billions of them bouncing around, and their collective average energy emerges as the property we call temperature. It's a statistical reality, not a fundamental property of any single piece. As Verlinde himself puts it, we use these big picture concepts that are totally derived from the microscopic world, but they really have no meaning at all in the language of that tiny scale.
So here's the crucial link where it all starts to connect. This idea of emergence is deeply, deeply tied to information. You see, physicists have this concept called entropy, which is really a measure of all the possible ways the tiny microscopic parts of a system can be arranged. You can basically think of entropy as the amount of information, the number of bits you'd need to describe that system completely.
So what on earth connects this idea of information and entropy to gravity? Well, the first major clues, the first real pieces of evidence, came from the most extreme, most bizarre objects in the entire universe, black holes.
The groundbreaking work of Jacob Bekenstein and Stephen Hawking showed that black holes have entropy. And if they have entropy, that means they contain information. But here's the absolute kicker. The amount of information a black hole holds isn't proportional to its volume like you'd expect. No, it's proportional to the surface area of its boundary, the event horizon. It's as if all that information is plastered onto a 2D surface.
This one clue led to a completely mind-bending new idea. What if space-time itself isn't this fundamental smooth fabric we imagine? What if it's an emergent structure? Something woven together from a deep network of interconnected, entangled bits of quantum information, the very building blocks of reality.
Okay, so this brings us all the way back to our original mystery. If gravity really does emerge from some deep layer of information, how does that solve the puzzle of dark matter?
This chart shows the problem in a nutshell. Based on all the stars and gas we can see,
The stars on the outer edges of a galaxy should be moving way, way slower than they are. I mean, they're whipping around so fast the galaxy should just fly apart. It's like there's an extra gravitational pull coming from somewhere.
Now, the standard explanation is to just surround the galaxy with a giant, invisible halo of dark matter particles. But Verlinde's theory, it offers a completely different answer. It suggests this extra gravity isn't from missing matter at all, but is an emergent effect from the vast sea of information that makes up spacetime itself.
Okay, so here's how the logic unfolds step by step. First, just imagine spacetime isn't smooth, but it's woven from countless quantum bits. Got it? Okay, step 2. The ordinary matter in a galaxy creates a kind of dent in this fabric, displacing some of that underlying information. This leads to step 3. The universe naturally wants to maximize its entropy, its information, so it responds with this elastic-like pushback to restore that balance. And that final step, that push from the information all around, that's what we experience as gravity, including that extra pull we've been blaming on dark matter.
Verlinde uses a fantastic analogy for this: silly putty. If you drop it, it bounces like a solid ball, right? That's a short timescale event, kind of like gravity in our solar system, which Einstein's theory describes perfectly. But if you leave that same silly putty on a table for a few hours, it slowly flows and deforms. That's a long timescale effect. This new theory suggests gravity acts just like that, behaving differently on the vast scales of galaxies.
So, if this idea is correct, it represents one of the biggest paradigm shifts in the history of science. I'm not kidding. It reframes our entire picture of what reality even is.
The sheer amount of information we are talking about here is just staggering. According to this theory, the information content of our universe is a 1 followed by 120 zeros. That's the informational blueprint for absolutely everything we see. So the ultimate takeaway here is that we may have been looking at things completely the wrong way around. Maybe the universe isn't a collection of particles and forces that happen to contain information. Maybe the universe is information, and all the stuff we see, particles, forces, even space-time itself, are just things that emerge from it.
And this leaves us with a final, really tantalizing thought. If everything we experience, space, time, gravity, matter, is just the big picture output of an underlying quantum information process, what does that really mean for the nature of our reality? Are we living inside some kind of giant quantum computer? Something to think about.